In this video, we are going to study about the limits of functions. We are going to start the limits of functions, and the first object it's going to be functions. And with this video, we are going to learn the domain of functions, and we are going to start actually the domain of functions and the type of function. And we studied, if you remember, we studied about the functions when you were at second grade, and we are going to study or review a bit about the functions because our main topic is limits of functions. If you remember the function, here this is the graph of the function, and the value a there is on the coordinate system, and on the y value we have b. And fa is equal to b, it is given. If you remember, it was operator, and it can be like fx is equal to, we can write like one function 2x plus 1. I can write here fx is equal to 2x plus 1. And the important part here, fx is equal to y, so y is equal to 2x plus 1. There are two sets here. This is the A set, and the elements are x, and the set B, or I can rename the sets like D and R, because this D and R has different meaning. D means domain, R means range, and x goes to y. The relation is called between them f. So fx is equal to y. This relation is 2 times of the domain variable, domain element of the domain, 2 times of the x plus 1. The relation between the x and y is that one, and 2x plus 1. Here, if I choose for the x1, y it's going to be equal to 2 times 1 plus 1, and that's equal to 3, which means x is equal to 1 and y is equal to 3. And we can see this one on the graph. Here, this is not line, but except it's like a line. If this value is 1, then this value is going to be equal to 3. And as I said before, D is where we are choosing the variables, represents the domain, R represents the range, where is the images, variables and images, and this operator, f operator, is called the function. Also, we name the y as function. Y is equal to fx because y is equal to fx is going to be. And how the operator works, well, we are choosing, I choose 1 for the variable here x, and I can choose another value for another example. For f2 it's going to be equal to 2 times 2 plus 1, which is equal to 2 times 2, 4, plus 1 is going to be equal to 5. So when x is equal to 2, y is equal to 5, it's going to be. Y is equal to 5, it's going to be. So we know this relation, fx is equal to y is going to be. Okay. Here, the important part at this subject, at this chapter, domain of a function for us. We have 4 types of function at this part: a polynomial function, rational function, radical function, and the last one is going to be exponential and logarithmic function. For the polynomial functions, the domain is R. What is the main part of this domain of function? Now I said we are going to, when you write fx is equal to y, I have chosen for the x some values. I have chosen 1 and 2. And for the fx is equal to 2x plus 1, I found 1 is equal to 2 times 1 plus 1, 3. 2 is equal to 2 times 2 plus 1 is equal to 5. But for radical function, for polynomial function, we don't have any problem. Domain, it is R. It means that you can choose any value for the variable x. You can choose 1, 2, -1, 3, any value for the domain you can choose. √2, -√7. So R here, when you say domain is R, for the x as a variable, you can choose an element that you want. So for finding the domain of the function for the polynomial function, we are not doing an operation. When you see the other types, you are going to understand what I mean. And main part of here, domain of a function for the polynomial part, to understand that is polynomial or not. For the polynomial functions, the important part, the power. Power is going to be natural number. Z plus means, if you remember, and Z is the integers set. Z is the integer set. From -infinity it's coming, and -4, -3, -2, -1, 0, 1, 2, 3, and 4 we can write. Then 3 points we are going to put, and these 3 points represent till infinity it continues. And 0 plus, when you say 0 plus, this is the Z plus represents this side, 1, 2, 3, and 4. And 0, Z plus union 0 means this one, which is also called natural numbers. Okay, so we are going to try to find that the polynomial is, the function is polynomial or not, actually, for the polynomial function, to understand the domain of the function. Okay, now the function is here. There are different type of functions here, and I'm going to find is it polynomial or not. Now fx is equal to -8. Is it polynomial or not? Yes, it is polynomial function, because here we have invisible variable, which is x to the power of 0, and I want you to write here x to the power of 0 is equal to 1, and the power element of z plus union 0. So this power is equal to 0, which is at the same time 1, and fx it's going to be equal to -8 to the power of 1. Fx is equal to -8. So this is polynomial function. So the domain of the function is all real numbers. Okay, this is for the first one. I'm going to solve for the B and C. D and E, it's going to be only E. Maybe it's going to be homework for us. Okay, the second one, I'm going to analyze the C. C for x squared minus 3 to the power of 3x to the power of -2. Since -2, this -2 I'm talking about, this -2 is not element of natural numbers. The function is not polynomial. Function is not polynomial, so the df is not equal to r. This is radical function, rational function. So we should find the domain with respect to this, and we are going to study that one later. We don't know now domain, but if it is polynomial function, like the last one, for this is polynomial function, because all the powers here 56, 45, 2, and here times x to the power of 0 there is, but we are not writing that one. X to the power of 0 is not written, and this is polynomial function. This is polynomial function, so df is going to be equal to r. If you understand that the function is polynomial, we are not doing an operation for the domain. Domain is directly r we are writing. So this function is polynomial and this function is not polynomial. You should find by yourself this one. Okay, let's continue. Okay, the next function is rational function. For the rational function, domain all real numbers different than hx, which is the denominator here. Denominator is equal to 0, or we can say like this: hx cannot be equal to 0. hx or hx cannot be 0. This is going to give us the domain. Here there are some examples. I'm going to explain on the examples. The function is fx is equal to when 2x minus 3 over x plus 1. X plus 1. The denominator is x plus 1, and x plus 1 cannot be equal to 0. Actually, the reason for the denominator cannot be equal to 0 because of the definition of the rational number. Rational numbers, if you remember, rational numbers we were using q. A over b is element of rational number. Element of rational numbers, which is q, where b is not equal to 0, because when b is equal to 0, the function or the value is undefined for us. So when the value x plus 1 is equal to 0, it means that it is undefined. So x plus 1 cannot be equal to 0, x cannot be equal to minus 1. X cannot be equal to minus 1 means all real numbers can be, except minus 1 cannot be. So domain of the f function for the first one is going to be equal to all real numbers except minus 1. Okay, for the second one, x squared plus 5 over x minus 5 times x plus 2. So the denominator for the second one, this is the second one, it's going to be x squared plus 5 over x minus 5 times x plus 2 is going to be, we are going to use the same method. X plus 5 times x plus 2 cannot be equal to 0 here. It means that x minus 5 cannot be equal to 0 and x plus 2 cannot be equal to x plus 2 cannot be equal to 0. When multiplication of two things is equal to 0, you remember, 1 by 1 they should be equal to 0. Here it is not, so 1 by 1 they are not going to be equal to 0. Okay, x is not equal to 5 and x is not equal to minus 2 is going to be. So domain of the f is going to be, I used wrong notation here, is going to be all real numbers except 5 and minus 2 is going to be. Okay, if we solve more examples, here we have some examples. 5x plus 10, define the domain of the function. So this cannot be domain. We understood that one. 5x plus 1, 10 cannot be equal to 0, pardon. We understood that one. We are going to do like this. 5x plus 10 is not equal to 0. 5x is not equal to minus 10. 5x is not equal to minus 10 over 5. And x is not equal to minus 2. Actually, when you replace by minus 2, you are going to understand that value minus 2 is going to make the denominator 0. 5 times minus 2 minus 10 plus 10 is going to be equal to 0. So undefined. So we are not going to use in the domain -2. So for the domain of f, d of f is all real numbers you may use for your function as a variable x except this number, which is -2. Solve similar exercise like b. That's why I'm going to solve the last one, the c1. And the c1 here, x squared minus 2x minus 8 we have. And we are going to find that x squared minus 2x minus 8 when it is not equal to 0. And we are going to solve this question like like factorization, how we are solving this kind of quadratic equations. X squared minus 2x minus 8 is a quadratic equation. When it's equal to 0, we were factorizing. And the factorization method here, -4 it can be, and -4 and +2 it can be. So this is going to be -4x, and this is going to be +2x, and the sum is equal to -2x, it's going to be. And x minus 4 times x plus 2 is going to be equal to 0. And x1 is equal to 4, x2 is equal to -2, it's going to be, it is not equal to 4, and it's not equal to -2, it must be. So 4 and -2 makes the denominator 0. That's why we are not going to take these two values in the domain, and we are going to subtract from all values, all real numbers except -2 and 4, it's going to be. And I'm doing here curly parentheses, which is parenthesis sign, because only we have two elements here, -2 and 4.